Hi, Dr. Brian Kaufman, a retired family doctor, a CLL patient myself, and the co-founder, executive vice president, and chief medical officer of the nonprofit CLL Society, reporting from day 2 of ASH 2020, the American Society Hematology's annual meeting and exposition. Today began with special oral sessions on biology. And frankly, while these were extremely important, they were often quite complex and require a significant background in cell biology, pharmacology, and immunology. Nevertheless, I'm going to walk you through some of these a little bit later on. There were also 2 interesting oral sessions on what's called outcome results. One that was specific to CLL that showed that ibrutinib outperformed chemoimmunotherapy in the real world and not just in clinical trials, and one on phase 1 trials across multiple blood cancers that documented just how unusual it was to have such high response rates in phase 1 trials as was noted with the BTK inhibitors like ibrutinib. And of course, these sessions were timed that they overlapped with each other. There was also many very interesting posters, including 3 on frontline use of ibrutinib in high-risk CLL patients, those with deletions of the 17th chromosome or TP53 mutations. Bottom line, it works very well, but we need to find ways to do even better. And there were 2 on the potent combination of ibrutinib and venetoclax, with one trial that used venetoclax first and then added in the ibrutinib, and another that did it in the reverse order, both with very significant success. Let's start with some other posters. Here is one that caught my interest, and it was presented by a radiologist, not a hematologist, Geraint Narang. The title was "The Clinical Relevance of Residual, Persistent, and Elongated Abnormal Sized Nodes by Longest Diameter in Patients with Chronic Lymphocytic Leukemia, Otherwise in a Complete Remission." I was particularly interested in this because I'm part of the 13.8% of patients that have a partial remission because one of my lymph nodes never shrank back to normal after my CAR T therapy. Its longest axis stayed above 15 millimeters, creating a skinny, but by stringent criteria, abnormal lymph node. He argues that patients like this, patients like me, with everything else normal, should be reclassified as having a complete remission, and I fully agree, and the data is starting to support that. Another poster was from the ICICLE trial. Ibrutinib and obinutuzumab in CLL, MRD, or measurable residual disease responses, sustained for several years with the deepest MRD depletions in patients with 1 year prior ibrutinib exposure. This was presented by Dr. Andy Rostron from Leeds, showing that adding obinutuzumab to patients taking ibrutinib not only deepened remissions, but led to durable, undetectable MRD remissions, in some cases lasting many years. This is especially true when the obinutuzumab was added to patients after they'd been on ibrutinib for a year. This may be because ibrutinib gets the CLL out of the lymph nodes and into the blood, and obinutuzumab is particularly good at cleaning out CLL in the blood and marrow, especially when the disease burden has been diminished by a year of being on ibrutinib. Let's cover some of the highlights from the very first oral session, the biology sessions. CLL biology and pathophysiology, or in other words, what's going wrong in CLL, excluding therapy, treatment resistance, and prognosis. Hold on to your hats. This is going to get complicated, but I'll try to get to the gist of it for you. The first talk was by Dr. Aaron Lipsky from Weill Cornell Medical, titled "Single Cell Multi-Omics Reveals distinct pathways to survival of admixed BTK C481 mutant versus wild type in clinically progressing chronic lymphocytic leukemia. Let's explain this. Here's the problem he set out to solve. Folks on ibrutinib have CLL progression when less than 10% of their cancer cells have a mutation at C481 that prevents ibrutinib from binding and blocking the B-cell receptor, BCR. That's how ibrutinib works. It blocks the survival signals from the B-cell receptor. On its surface, though, it makes no sense. Why should the drug stop working when 90% of it's still being blocked? So let's discuss what challenges faced Dr. Lipsky and his team. The technical challenge in studying this was enormous. His lab developed tools that allowed him to interrogate single cells at a time so that he could separate gene expression in the resistant cancer cells with the mutated C481 that didn't allow proper binding from the majority of cells that were, quote, wild type, close quote, meaning that they were not mutated. Only with this very sophisticated lab technology was it possible to tease out some answers. It's complicated, but it appears that the 10% are a bad influence on the good 80%, making them less sensitive to ibrutinib. Now it gets really interesting. The research suggests they do not do this by preventing ibrutinib from doing its job of interrupting B-cell signaling, but by their effect on the microenvironment that the good cells, if you can call any cancer the good cells, the effect on those cancer cells' microenvironment, and engages other pro-survival signals like Notch1 and IL-4 that tell those 90% cancer cells to stay alive. Another cell biology talk was B-cell mediated resistance to CAR T-cell therapy by insufficient activation is CAR independent from Mackenzie Collins, Bachelor of Science at the University of Pennsylvania. She showed that the reason for CAR T failure, which is too common in CLL, is not only from our well-described exhausted T profiles, so our T cells are lazy and don't always do the job that they should, but that the CLL cells themselves may insufficiently stimulate our CAR T cells to proliferate and become active. This has important implications on how to rev up the response rates for CAR T cell therapy. The final biology session I'll discuss was presented by Dr. Clive Zent from Wilmot Cancer Center, University of Rochester, New York. Ibrutinib's off-target inhibition inhibits antibody-dependent cellular phagocytosis and not efferocytosis of CLL cells. Don't run away. I'm going to keep this real simple. Dr. Zent explains why ibrutinib therapy does not seem to benefit from the addition of rituximab, a monoclonal antibody that is known to very much deepen responses when added to chemotherapy and when added to venetoclax, but not so with ibrutinib. He believes that the reason for this is due to the, quote, off-target, close quote, effects of ibrutinib on other enzymes or kinases besides BTK, and that these other effects, these other kinases interfere with not just rituximab, but many other monoclonal antibodies. In other words, ibrutinib blocks more than BTK, and this has some risks associated with it, as well as some benefits. The takeaway from this is that it may not be the case with other more newer generation, more targeted BTKs, such as acalabrutinib and zanubrutinib. Tomorrow is day 3 of ASH 2020, and I promise there'll be a little less basic science and more clinical results. So I look forward to talking to you then. Stay strong. We are all in this together. Dr. Brian Kaufman.